In this video, we're going to be looking at solving rational equations, oftentimes by cross-multiplying, occasionally by finding a common denominator. These are, your more basic rational equations, ones that are going to kind of be limited to solving degree 2 at the end. Okay, we won't need to solve any third degree or higher today. Okay, so I'll start with a pretty easy one. 2x plus 1 divided by 4 is equal to 7. And then we did these, I think, in the first unit of the year. I think y'all would know how to do this. Pretty much 100% of us in my college algebra classes would be able to solve this. What would be the first step? Yeah, definitely. Multiply by 4. Okay. So I'm going to start by multiplying by 4. So I'll say that 2x plus 1, maybe I'll just say multiplied by 4 over 1 is equal to 7 times. You want to multiply by the same thing on both sides. Don't want to change the validity of the equation. So what I'm going to do, okay, we know from a couple times ago that works. We've known that. And so I've got 2x plus 1 equals 28. 7 times 4 is 28. I'm going to subtract 1, and I'll have 2x equals 27. And then I'll divide by 2. So x is going to be 13.5, or 27 divided by 2. However you like it. Here we got another one, pretty similar. And so I think this is one that I would like for y'all to attempt to do on your own. Okay, so y'all get at it, see if you're doing it right. If you're watching at home, you can just follow along with my work. So we mostly cross-multiplying. Is that how we were instructed to solve this type of thing in Algebra 1? Some of y'all were in my Algebra 1, but some of us weren't. I've even seen Algebra 1s where you weren't allowed to cross-multiply, where I think that might be a little extreme. But really what we're doing is we're multiplying both sides of the equation by 4, and we're multiplying both sides of the equation by x minus 4, okay, at the same time. Okay, so we do that, we distribute, and then solve. Okay, I'm pretty sure that we're solid on these. Here we got another one. I've got a bunch of time today in class, so why don't we just go ahead and do this one as well. Okay, so what I'm going to do is I'm going to cross-multiply. That's going to be my general strategy. Now, if you want to just multiply both sides by x minus 4 and multiply both sides by 4 in separate steps, because it's how you did it in Algebra 1, that's cool. No judgment. Okay, but what I'm going to do is I'm going to say that 4 times x minus 3 is equal to 5 times x minus 4. Then I'm going to distribute. I've got 4x minus 12 is equal to 5x minus 20. And then maybe I'll subtract 4x from both sides. And I'll add 20 to both sides. So 20 minus 12 is looking like 8 equals x. Okay. So this is really, I feel like, something we can do. Okay, here's one for you to try on your own. Okay, this one's going to involve a little more distribution and a couple more steps, and it's got, kind of a strange end, but I think this would be a good thing to kind of explore on your own. And if you're watching at home, you should definitely pause the video because the answer is just about to pop up in a couple seconds. All right, here you go. So we're going along and everything's going well, and it's like, oh, the x squareds are canceling each other out, so I won't have to factor or use the quadratic formula or any of that stuff. But then it's, oh no, too much had canceled out, and I got negative 8 equals negative 3. And I think it's just the right time. It's been just long enough since we've had an equation come back like that that it was good for us to see, okay, when I do get something that's patently false, like -8 equals -3, I can conclude that there's no solution to this equation. Okay, here's one that is going to have a solution. We got x plus 2 over x minus 5 is equal to x plus 6 over x plus 1. So I'm going to start by cross multiplying. I'm going to, kind of distribute out each side. So this is x squared plus x plus 2x plus 2 equal to x squared minus 5x plus 6x minus 30. So this is, we're going to just combine the like terms. This is plus 1x minus 30. Bless you. Okay, now I'm going to subtract an x squared from both sides. Now it's really just, we're much better off for not having, we're not going to have to factor, we're not going to use the quadratic formula, kind of complete the square, nothing like that. And then I'm going to kind of work on the x's. Maybe I'll just subtract 1x from both sides. And so I'll have 2x plus 2 equals -30. And I'll subtract 2, divide by 2, and get myself an answer. All right, and then this is going to be kind of a pretty typical problem of the ones that we're going to have to solve today. And I want you all to solve this one on your own, however you would first think to solve it. Don't solve it how you think I want you to solve it. If you're watching at home, I'm going to pause the video so that you can really go through this, try to solve it your way, and see which way you're going to do it. And you should definitely pause because the answer is about to show up. Okay, here you go. So my first thought when I looked at this was multiply both sides by x. But I know that some of us would maybe want to find a common denominator. Okay? In my third period, we've had another strategy employed, which I would not have considered. And so I'm going to zoom out a little bit and show you that one as well. Okay, the common denominator, once we get here, we're going to say, okay, well, I can just multiply both sides by x, or just clear out that denominator. You can get to x squared minus 5 equals 4x, kind of like you were right over here, and then you'd solve the same way. It's going to end up with x equals 5 and x equals -1. But this other way is not what I was expecting, so I'm going to kind of give myself some more room, and we'll call this cross multiply. Okay, and so what 147 said she did was subtract x to the other side. So I've got 4 minus x. She put it over 1 and then cross multiply, which I think is really, all of these are the same technique, just doing it different ways. But I do want to show you that all of these are valid, and that, as long as we are taking valid algebra steps along the way, no one way is better than another way. So I've got -5 equal to x times 4 minus x is going to be 4x minus x squared. Okay, I'm going to get everything to one side, set it equal to 0. X squared minus 4x minus 5 equals 0. You factor. You get x equals 5 and x equals -1. Okay, so it's really, how do you want it? Okay, here we've got one with different denominators. And now, my recommendation when you have different denominators is going to be that you find a common denominator and get everything in terms of one denominator. Okay, so I see an x, a 4x, and an 8. So the x and 4x, their least common multiple would be 4x. But then when you put that 8 in there, I feel like we could just go for 8x. And that's what I'm going to try for as my denominators, 8x. So I've got 8 over x. And I think, what do I need to multiply x by to get 8x? And that's going to be 8. But I don't want to change the fraction, so I'm going to multiply by 1, which is 8 over 8. And then I'm going to do the same thing with 1 over 4x. 1 over 4x, I'm going to need to multiply that by 2 to get to 8x. I don't want to change it, so I multiply by 1. And 11 eighths. 8 is missing that x. Okay, so I do a little bit of that. And I'm going to say that now I have 64 over 8x plus 2 over 8x is equal to 11x over 8x. And then what we can do is we can take both sides of the equation and multiply them by 8x, which will functionally kill off the denominators. And then we can just have it down to 64 plus 2 is equal to 11x. And that sounds pretty promising. The question was, should I combine them first? And, maybe I should. So I'm going to say I've got a common denominator. Isn't the whole point of getting a common denominator so you can add two fractions? So, yeah, I'm going to do that. And I'm going to add those together, and I'll get 66 over 8x is equal to 11x over 8x. And now, okay, you could multiply both sides by 8x and kill off the denominator, or you could cross multiply. I mean, you're just going to end up with this kind of like redundant 8x. So either way, however you like it. And I've got 66 equals 11 times x, and so I think that means that x is going to need to equal 6. Here we've got one kind of like one I did before, but I think it's going to work out a little different. And so this one I am going to, since I only see one denominator, I think it would be easiest to deal with this by just multiplying both sides by x. So I'm going to have, say, 8x squared minus 3 over x multiplied by x is just going to be 3 is equal to 2x. Then I'm going to subtract . Oh, no, this one is not working out how I thought. Okay, is this thing factorable? I think it actually might be. Yeah, I was hoping that it wasn't. Okay, so I'll just ask the same question I was going to ask anyway. What would we do if it was not factorable? Or if we just couldn't see how to factor it? What kind of technique would I take? What would I use? Yes, I would use the quadratic formula. If it is not factorable, or you can't figure out how to factor it, the quadratic formula will always work. Okay, well, this one being factorable, I'm going to factor that way. Okay, so I'm looking for two numbers. It's been a while since we've done this in class. We're going to multiply 8 and negative 3, and we're going to find two numbers that multiply to 24 while adding to negative 2. That's going to be multiplied to negative 24 while adding to 2. And so I think that's going to be negative 6 and positive 4. So I've got 8x squared. I'm going to split the 2x into positive 4x and negative 6x. I factor by grouping 4x times 2x plus 1 and a negative 3 times 2x plus 1. Factor out the 2x plus 1. And then this is going to be equal to 0 when x is either equal to negative 1/2 or when x is equal to positive 3/4. Okay, now question from the front was, is it really okay to just multiply both sides by x? Like what's really going on here? And well, that's the type of question I like. So I'm going to show you what I'm doing when I multiply both sides by x. Okay, x times 2 is 2x. I think we're in agreement. But then when I go and distribute the x, I'll have x times 8x is 8x squared. And then over here, I have minus 3 over x times x over 1. And so really that is just 3, right? Oh, it looks like it's lagging a little bit on my screen. But yes, and so that's why we end up with 8x squared minus 3 is equal to 2x. That's certainly a valid question. All right, this one's got two different denominators that have x's in them. So that's, maybe kind of an extra layer of difficulty there. And I think looking at this, I still want to multiply both sides by x. Do you see why I want to multiply both sides by x on this one? Anybody? I'll still have a denominator, but it'll at least get rid of that 1 over x, right? Okay, so that's something I can do. So I'm going to say x times 5 minus x divide by x minus 5. So what's going on here? Plus 2x, and we've got to multiply everything by x. 1 over x times x is 1. Now, okay, so after some discussion in here with the video pause, we've decided we're going to actually deal with this 5 minus x and x minus 5. And because 5 minus x, we can factor that. We can factor a negative out of that. So I'll have negative x times, well, the x will become positive, and the 5 will become negative. Oh, whoops. And then we can cancel these things, the way that we did a couple of times ago. Plus 2x equals 1. So I've got negative x plus 2x equals 1. That's 1x equals 1. Okay, this one was unusual. I don't really know what to make of this. Okay, and here we have one where it looks pretty beastly. But I'm telling you, it's not going to be that bad. Okay, so what we're going to do is we're going to get a common denominator of x squared minus 3x minus 18. Because if I start by kind of factoring this guy, that's x minus 6 times x plus 3. And, as a result, I can just kind of multiply the 4 over x plus 3 by x minus 6 over x minus 6, and the 5 over x minus 6 by x plus 3 over x plus 3 to get a common denominator. And that's what I'm going to do. So I've got 4 over x plus 3. This is missing the x minus 6, so plus, okay, I've got the 5 over x minus 6. Then I'm going to multiply by x plus 3 over x plus 3. And that's equal to 4x plus 1 over this thing that we decided was x minus 6 times x plus 3. And I'm actually going to distribute these. So I've got 4x minus 24 plus 5x plus 15. We've got the common denominator, so we're using it. That's equal to 4x plus 1 over x minus 6 times x plus 3. And now I can kind of clear out the denominator. All right, the video connection looks like it cut out for a second. I'm not sure how long it was out, but we've got ourselves a common denominator. We're going to clear out that denominator. And so I'm left with 4x plus 5x. I'm going to actually combine like terms right here. 9x, negative 24 plus 15 is negative 9, equaling 4x plus 1. I'm going to subtract 4x, and I'll have 5x, add 9, and I'll have 10, and I'll conclude that x is equal to 2. Now this is going to be the last one I've got for you today. It's got 2x plus 5 over x plus 1 is equal to x minus 1 over x minus 3. And so, you know, it's kind of set up for cross multiplication. I'm definitely going to do that. I'm going to say 2x plus 5 times x minus 3 is equal to x plus 1 times x minus 1. And then I'm going to actually distribute. I've got 2x squared. I've got negative 6x and positive 5x is negative 1x equal to x squared minus 1, right? Because it'll be x squared plus x minus 1. Now I'm going to set this thing equal to 0 so that I can solve it. And I've got x squared minus x. I'm going to add 1 back as negative 14 is equal to 0. Then I think to myself, okay, let's factor this thing. What two numbers multiply to negative 14 and add to negative 1? And it's like, oh, that's not going to go well. Only thing I can think of for 14 is 14 and 1 and 7 and 2, and neither of those have a difference of 1. So this is not going to be factorable. So I think to myself, what do I do when a degree 2 polynomial is not factorable? I use the quadratic formula. So I'm going to say x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's going to be 1 plus or minus the square root of 1 plus, that looks like 56, so square root of 57 divided by 2. And that's as far as I'm going to be able to go. That's all I've got for you today. I just want to remind you that, you know, sometimes these things could work down and then require use of the